You've connected to Cisco Unplugged.
Hello, everyone, and welcome to episode 77 of Cisco Unplugged, your show for all things wireless. I'm Dan Klamert, your host, and I'm back here again with Al Dumdei. Hey, Al, how are you doing?
Hey Dan, good good to have you back. I think
Yeah,
we did our best last week or 2 weeks ago. I mean, well, last session while you were away, but
I'm sure you were fine with that. I saw a little bit of it. It was a good episode. I was on a plane at the time, so but thanks for filling in for me, and you did a great job. I appreciate you. And there was a little bit of a debate before the episode here, what episode number this is. 'Cause we had the Yule log around the holidays. We had the special for the back to school. So I guess we're going with 77 at this point. We'll have to look into a recount later, maybe.
it's about the content.
Exactly. That's
So,
true.
yeah.
So,
Speaking of which,
yeah,
yeah, looking forward to today's content. We have our
yes,
brothers from the north down. Uh,
yes.
and I haven't told these guys, you don't have to live in the Arctic Circle, right? So, but anyway, we'll get into that discussion later. So,
Yeah. Well, when you were saying it's good to have me back, I was thinking, yeah, it's good to be back until this morning. I was shoveling snow. Then I was not thinking that I was happy to be back shoveling snow, but I'm happy to be back here though. So,
yeah.
um, yeah. So this week we've got part two. I think it was episode 70 that we talked a little bit about private 5G and Wi-Fi better together. And we had Derick on the show. And so today we're going to dive a little deeper dive into the story. And I'd like to welcome back Derick to the show. How are you doing, Derick?
Hey, how's it going, guys? It's glad to be back, and it's a new year, and hope to be able to drum up some more excitement on Cisco's private cellular. I'm
Yeah.
actually joined by my colleague Matt Faulkner, who is
Hi
also,
guys.
Hey, Matt, how are
Yeah.
you? I was going to
both
welcome
of
you
Good.
us,
next. Thank you very much for joining us.
yeah, both of us are, in the up north here, enjoying the snow and the ice and cold weather. So I figured if we tag team a bit and talk about private cellular, and then take a layer of the onion off and dive into a little bit more detail in terms of some of the one specific use case that we're starting to see a lot of interest from our customers going forward.
That's
And
perfect. Before we do, I got a couple reminders here for the viewers. We just gotta go through. We do take questions via Slido, so you'll see the links on the screen. You can join the Slido there. Also, if you're watching via YouTube, the YouTube channel, youtube.com/@getunplugged. Down below the video, there's the link to the Slido to join there. You can submit your questions. We do get to many of those live on the show, or we'll answer them in Slido as well. Either way, we'll get those squared away. And so don't hesitate to ask questions. And when you are out in the YouTube channel, I mentioned the link already. Make sure that you subscribe and like. It helps us reach new people. And we're closing in on a milestone here as far as subscribers. So thanks for watching. Thanks for tuning in, and turn on the notifications bell so you are notified when we do go live with great content like this. So with that, let's dig in here, Al, and let's get unplugged here. Let's dive deeper. I'll turn it over to, I guess, you, Derick.
I
You want to
I
talk a
have
little
one
bit
quick
more?
question for
Yeah.
Dan, for you and Derek, because so is it true that when you have teenagers, you don't have to shovel anymore? Because I've heard this. So I think Matt, isn't that what you heard earlier too? Is that
Yeah, I did.
yeah, when you have teenagers, life is easy, right?
I
Right,
wish that
right.
was true, but my experience has been that they tend to talk back at you. They call you an old man. You need the exercise. Why
Hey,
did you
Al,
buy
if
that
it
snowblower?
if you don't mind the shoveling after noon, then you're fine. If there's any shoveling to be done in the morning, not so much.
So I
So
guess that's myth busted, huh?
It's a myth
very
busted.
much so.
Exactly.
Exactly. Sorry, I didn't mean to interrupt.
That's a good
Oh,
one.
that's a
That's a good one.
it's a good one for especially for today when we're
Yeah.
having this clipper going through. But
Yep.
thanks. So yeah, guys, what I was hoping to do was basically leverage on top of what I already presented in episode 70, which is a basically an overview of how Cisco Private Cellular and Wi-Fi, is a better together story for our enterprise customers going forward. as it allows for what I call a unified access strategy, and allow for the experience from a device standpoint, whether it's connected via Wi-Fi or cellular, to be seamless. What I would like to do in this episode itself is to focus on one specific aspect of that, which is that integration that we talked about briefly in the episode 70, and that's why I'm joined by Matt, who he and I have been focused on the variety of use cases that leverages on top of that, and specifically dive into one specific of these use cases that a lot of our enterprise customers are focused on as well. So if you remember, and this is from the previous episode 70, I showed this slide that talked about this is your typical deployment that you normally would see from a private cellular standpoint, from a Cisco standpoint, whereby that box in green in the middle of the slide deck, in the slide itself here, is the packet core, or the equivalent to what a wireless LAN controller would look like in the Wi-Fi space. Not exactly the same, but it's similar in that concept from an architecture standpoint. And then you as a customer would then wire up one or more multiple cellular radios, both indoor as well as outdoor, to provide a cellular footprint, whether that's LTE or 5G, for your devices to connect into. And the reason people are actually looking at that is because we're now starting to see more than just, hey, I need to connect my iPhone, I need to connect my tablet. It's more about embedded systems or robotic systems or very specialized systems that are coming more from the OT side of the shop that requires dedicated, mission critical oriented networking so that they can do nonstop operations. So if you have a warehouse, for example, and you got these autonomous guided vehicles, these stacking robots that are taking pallets from one end of the warehouse to another end of the warehouse, they really need a reliable, mission critical oriented infrastructure to be able to operate. Because if they lose connectivity, or if their latency profile goes out of whack, or if they experience, for whatever reason, someone opened the door to the washroom and the radio environment changes slightly and they experience a packet drop, or 10 or 100 or 1,000, they stop. Because the autonomous guided vehicles need to have that reliable connection to their controllers for them to be able to do their job. That's a disaster in a warehouse environment, because you typically would not want to have your robot stop all of a sudden for no apparent reason, or because you went to the washroom. These types of environments are now calling for these mission critical based infrastructure based on cellular to be deployed there, but we also want to use that cellular infrastructure for other use cases. And one of the use cases we'll certainly talk about a bit later on is guest access. License spectrum is the key and central advantage to a private cellular setup, because it actually allows for you as an enterprise customers to guarantee the radio performance itself. You're not sharing that spectrum with anyone else. So when it comes to engineering design, in terms of edge of cell performance, in terms of interference mitigation, you have a known entity that you can work with, so you can design these systems around that. And that's why cellular infrastructure, private cellular infrastructure, or even hybrid-based private cellular infrastructures are becoming very much more popular with our enterprise customers, especially on the industrial side. A key area where we tend to see a lot of questions coming up is, how do I provide that integration with Wi-Fi? Yeah, because what I really want to see is that I already have a Wi-Fi infrastructure in my carpeted offices environments. I have my boss, my administrators, my technicians. They're sitting at the desks. They have laptops, they have desktops, they have tablets. They're all connected via Wi-Fi. And the idea is that if they walk into the warehouse, for example, and they need to check out a robotic system that's gone down for whatever reason, you would like to have that device be able to always be connected, so that whatever services, whatever augmented reality systems, or any other applications that they are using to be able to service that particular piece of equipment is connected. And you may not have a proper Wi-Fi footprint in the warehouse. That's one of the reasons why you deploy private cellular. So the idea to be able to hand off between a Wi-Fi infrastructure and a cellular infrastructure becomes very, very important. That's seamless session handover between the Wi-Fi as a radio type and the cellular as a radio type is an important thing. And the way Cisco actually achieves that is by thinking about, well, it's more than just the actual sessions that you have to hand off. There's a lot of policy, security, and other related capabilities that you've already built around the Wi-Fi system for that particular device that you also have to carry over to the cellular side. And the one place in an enterprise space for Cisco enterprise networks where this is defined is on a product called the Cisco ISE, the Identity Services Engine. People tend to use that to centrally manage wired as well as Wi-Fi connected devices from a policy standpoint. Who are you from an authentication standpoint? What are you allowed to do from an authorization standpoint? And where are you allowed to go from a security standpoint, as well as having the necessary accounting records being sent back to a security operations environment from a validation standpoint. So it made sense for Cisco when we actually were designing this private cellular infrastructure to say, in order for us to facilitate that seamless session transition between a Wi-Fi radio type and a cellular radio type, it made sense to integrate into Cisco ISE, and this is exactly what we have done. So what it means is we had to somehow glue together the way cellular networks typically operate when it comes to authentication authorization systems and the way a Wi-Fi system or a wired system typically operates from my authentication authorization system. Not easy to do because the Wi-Fi and wired guys tend to follow IEEE rules. They typically have something called a AAA system, authentication, authorization, authentication system based on radius, that does all that capabilities. And on the cellular side, we follow different standards. Isn't that always fun? And from a standardization standpoint, we tend to follow a different standard. We tend to do things differently. And you may be familiar with that in terms of how we do authentication on a cellular device. We all have heard about SIMs, these subscriber identification modules that we stick in our phones. That is a piece of thing that you have that ties to a private key setup with a subscriber management system that we actually have in the cellular world. That's how you authenticate cellular devices. That's how it's always been done. How do you glue that with an EAP AKA or EAP, EAP authentication process that we typically layer on top of a radius-based protocols. So the first step that we've done when it came to integration of our wireless cellular environment to a Wi-Fi cellular environment using Cisco ISE is to provide what they call secondary authorization. Keep the authentication as per standards from a cellular standpoint using SIM credentials. But now we tie it in so that, okay, we know who you are, but we're going to make a call to ISE to say, here's a person, he has this SIM credentials, his SIM identification, MSISDN identification, whatever it happens to be. What am I allowed to do? So now it becomes, from an enterprise customer standpoint, fairly easy to be able to backfill data into the ISE system to say, if you are Matt Falkner and you have this particular SIM assigned with this particular device, or if I get a request from an authorization from a device that says this is a particular SIM, I can tie it to Matt's profile and assign all Matt's credentials from a policy standpoint to the cellular side. So that's the first step.
Derick, and what I think is particularly interesting here is that this private 5G, 4G, 5G edge that you show at the bottom left here, that can actually be operated by a managed service provider.
Yes.
But even if you don't have control, or if you consume the infrastructure, the 5G, private 5G radios, as an example, through a managed service, you can still leverage the same ISE instance that you're using for your Wi-Fi or even indeed wired connectivity.
And that's a very good point, because in many offers that we see in the industry, Cisco and others, the private cellular infrastructure is offered as a managed service, i.e. there's a third-party entity that is actually deploying and operating that cellular infrastructure on behalf of the enterprise customer. But then you get this command and control issue. if I was the enterprise customer and I said, hey, I want to change the profile associated with a particular device, do I have to call this managed service provider and then wait for his or her process to be able to change the profile settings for this particular device? With this ICE setup integration that we are showing on this particular diagram, the answer is no, because the ICE entity is controlled by the enterprise customers. I can go in as the enterprise customers and change the profile setting without having to go back to that whole process, which tends to be more heavy-handed when it comes to the managed service provider. So you get the best of both worlds. You get the managed service SLA-oriented services and their expertise managing the actual cellular infrastructure on the private cellular side, but then you also have full control in terms of how your users are actually deploying and consuming that services, both on the Wi-Fi and the cellular side.
Derick, do you have some examples on what kind of ICE policies we can carry forward into the private 5G world?
Yeah, so there's a great lead into my next slide. So
there you go.
typical things that we do with ICE. So if I take one step back and look at ICE itself from a system standpoint, typically you look at, I want to be able to differentiate things. So I want to be able to group things together. So for example, the executive teams could have a different set of policy versus the local SCs on the account versus the administrators versus the tech that are running around in the warehouse versus guests that are walking around in this particular space. So the ability to group things might be different. So you can actually extend that to say, well, if you're an executive, you're going to get 1 gigabits per second worth of downlink throughput to your cellular device versus the administrator. The front desk administrator may only get 100 megabits per second because we don't expect he or she to be able to utilize that bandwidth. So being able to differentiate users and then set per group policies associated with these particular users is one of the key driving forces behind how ICE operates. So you can classify these endpoints, you can authorize these endpoints with these specific profiles from a device profiling standpoint, and we want to extend that to the cellular side. We can also do interesting things. In the past, we've been able to do what they call dynamic access control lists. The ability to say, you are not allowed to go to this particular section of the network because you are an executive, and the executive should have no business being able to mess around with my servers in the wiring closets, for example. That's an access control list that you can set up. That was simple and straightforward. People have tended to do that a lot in the past. We want to be able to carry that in the private cellular space as well. But what is becoming more and more interesting is this intent-based policies, having external systems access ICE and then having intent-based policies being instantiated and deployed there. And a big piece of that is something called security group tagging, SGT. So SGT is part of this whole zero trust-based model whereby rather than this outside in look, whereby we don't trust the outside infrastructure, the internet. We have to have firewalls protecting us from the big bad outside world, the internet. And inside, I trust everything. A zero trust model actually flips that around. It says we don't trust anything. So every piece in the infrastructure has to act as a quote unquote firewall. You always, before you allow a flow to go from one port to another port, or one IP address to another IP address, or one VLAN to another VLAN, you always check to say, is this allowed? So every entity in your network that's doing layer 2 and or layer 3 switching should be able to do firewall-based rules using something called security group tag. And the idea behind that is that what we normally do is that these devices at the end of the infrastructure, they typically would assign a tag, a tag to a flow. These tags could be like our badges that we normally would carry as employees, and these tags will be identifiable in ICE as, belonging to a group that has a certain security policy associated with that. And every time that flow pops through an infrastructure component, like a switch or a router or a packet core, a cellular packet core, we would validate that tag to say, you're coming from this particular tag, this particular badge, and you're trying to get access to that particular section of the network. Are you allowed to do so? So,
and Derick, it's not just zero trust, it's also the Cisco software-defined access architecture that is being supported here with private, or extended here, I should say, with private 5G. For those of you who are familiar with software-defined access, what we've done is we basically made the data plane of the private 5G packet core a policy extended node. So functionally, it's like having a policy extended node in a software-defined access architecture.
Very much correct.
Oh,
Yes.
interesting. So can you let's just maybe you can walk through an example. You had an example a little while ago. You said, hey, if I have a mobile device, I'm going to walk out into the warehouse, but I'm, while I'm in the office, maybe I'm on Wi-Fi. Walk us through, okay, I'm in Wi-Fi. How did I authenticate on Wi-Fi? What is my IP scheme at that point? Then I go to the warehouse. I'm able to, what's my authentication scheme with and what's my IP scheme? What I'm saying? Kind of walk us through that whole sort of transition, how that's going to work. Who makes the decision of, am I on Wi-Fi? Am I on cellular? Can you walk us through an example like that?
Yeah, and also assuming that's pretty seamless to the user too. I mean, this is this is pretty impressive here to kind of have the unified policy in the back end.
I love this stuff.
Yeah.
Yeah, so there's several layers to that answer, to that question, actually.
Yeah,
sure. But so let's first be very clear and upfront. The entity that does the decision as to what to flip to from a radio network access type is always the end device. So the end device will make the decision to say, hey, you know what, this Wi-Fi network is crap. Sorry. Say that out loud.
But you can set a preference on that too, right? Like you can ask. Okay.
We could. And we have partners, end device partners, that have modified the default device selection methodology to fit more of an industrial enterprise-based environment. So as an example, I work closely with a company called Zebra Networks. They actually build these specialized hardened tablets and scanners and devices for enterprise locations. And they've modified the Android-based device selection process because, we've all encountered this, that sometimes these devices tend to want to stick to Wi-Fi too long. They wait until the performance is really bad before actually say, okay, I give up, I'm going to go to cellular. So they have a more preferential process that they can actually flip to. And you can also set it to say, always prefer cellular over Wi-Fi, which is the opposite of what the default is. So yes. But the end device and the software system at the end of the day tends to make the decision as to what network they want to flip to. And you have options to customize this if you're smart enough about how to select that. What we have to do from a networking standpoint is when we authenticate, we have to make it as simple and straightforward as possible. And fortunately or unfortunately, the Wi-Fi world and the wired world, for that matter, tends to follow a slightly different authentication process profile than we had before in the past, which was an EAP-based authentication process. And then, of course, in the cellular world, we do a SIM-based authentication. So that's based on the chipset. So the two are not exactly the same. Although we can do some interesting things, and maybe Matt can talk about some of the work we're doing on the aka Prime stuff to sort of talk about that, as well as open roaming that can sort of address some of the key capabilities, especially when we consider outside public cellular infrastructures that we want to throw into the mix, so to speak. But at the end of the day, you still have that idea that one domain is doing SIM-based authentication, the other domain is doing EAP-based authentication. Okay, so we can address that from a technology and networking standpoint, depending on the approach that you want to take. But I think the more important thing is that once you've authenticated and you have control of both sides of the domains, you still want to provide a uniform authorization profile to the device. But that's really what's going to give you that seamless session experience that you're going to get between switching between Wi-Fi and cellular.
So in one case, I may have authenticated with a SIM. In another case, I may have authenticated with a profile, but it's seamless to the user, right? In that case, I'm on Wi-Fi and cellular connected to both. But now that just gets me connected. It doesn't get me a policy. Right. It doesn't tell me what to connect to, what I can do with what I can connect to, and all that sort of stuff. Okay.
And that's why that integration with ICE is so critical, because now I can pull in that policy. And if you already had a policy established on the Wi-Fi side, then cellular can actually consume that as well. where it makes sense and where the attributes make sense, and extend that with additional key attributes that make sense for the cellular side. So in the cellular world, for example, we have something called uplink and downlink aggregate maximum bitrate capabilities that we can set on the packet core, i.e., I can control the amount of bandwidth you're going to consume. Even though the spectrum allows for 1 gigabits per second, I can now dictate for this user, your downlink speed is X and your uplink speed is Y. You can try to get more, but you're not going to get it. You can sort of do that on the Wi-Fi side as well. There's newer technologies coming in the Wi-Fi 6E and 7 space that allows for that capability set, but it's not exactly the same. So, there's radio-specific types that we can do that you can actually add and augment to your policy depending on the RAD type. But at the end of the day, because we're doing authorization integration, it means that we're not forcing you to go to portals or do special, special processes to be able to get your profile back. We're not asking you to generate VPN connections or anything like that. We are basically making sure that when you flip from one radio type to the other radio type, you land on the same network with the same policy associated with what you had before in the past.
I find it interesting that from the cellular side, now we also have the ability to do SGTs, right? Because so I can keep that matching SGT on both sides, right?
Yeah.
So
That's right.
And I can actually use SGTs to determine, can I talk to, I may be on cellular, can I talk to this person on Wi-Fi? When I talk, communicate because of the SGTs or not, right? So I can set up all those policies within Wi-Fi, within cellular, between Wi-Fi and cellular, all of that sort of stuff with those.
And the key point is that the packet core acts as a policy extender. It enforces the policy. So even if I do hairpinning to the packet core from one cellular device to another cellular device, which never has to touch any of your networking infrastructure behind the packet core, I can enforce it still. So I can follow the standard SGT policy enforcement rules because the packet core acts as an enforcement entity in infrastructure.
And Al,
Yeah.
remember that these private 5G radios that we use to access, they're actually connected to the same campus infrastructure that you would have for Wi-Fi and wired. So you're not talking about a public 5G radio and then send traffic out to some public core of a mobile network provider. Everything is enterprise owned and you're leveraging the same campus. So that's why it's so important and so beneficial to keep the VLAN segmentation policies or the SGT policies consistent across these different access networks.
Well, and even if and we haven't gotten to the IP part of this yet, but even if my IP addressing is different for cellular than it is for my Wi-Fi, with SGTs, I can enforce the same policies.
Exactly.
Regardless. I don't have to write ACLs.
That's the key benefit of SGTs, right? Is decoupling policy from the IP addressing and segmentation, VLAN segmentation. Yeah.
I like to say it provides an abstraction away from the layer 2, layer 3 constructs that you've built.
Yep.
Even though we could potentially say, hey, you're on the cellular network. I'm at least because cellular has a different interface than the Wi-Fi. They're two different interfaces, and if you know anything about networking, you can't assign the same IP address to two different interfaces. Well, it sort of works, but it's sort of a lot of systems don't like that very much. You could assign different IP addresses on the same VLANs. So I can still enforce that capability and make it as cleanly as possible so that, when it comes to your latency profile that you have to manage for this robotic system that has to talk to a controller, it's similar. It's similar.
So Derick, how do we use that for guest access?
Yeah, that's a very good point. Why does this question come up? Because we've run into a lot of customers that says, I've deployed this private cellular, it's deployed in my infrastructure, it's great, it works. I see all these robot systems, I see all my employees walking the sites. But Derick, I have a problem. I have about 500 contractors coming on site every day. They're engineers, they're pipe fitters, they're electricians, they're whatever. They tend to do a lot of work on these large industrial sites. And they need service because they need to get access to support from their back-end people. They need access to manuals. They need whatever. They need all that networking capabilities. But my site has poor connectivity from a consumer cellular standpoint. A lot of times we find ourselves, these private cellulars are very popularly deployed in locations where consumer cellular services are very poor. And they, as a company, have a mandate to provide at least basic services when things go wrong. So how do I do an emergency call? How do I make sure my contractors are, in areas that they're supposed to be and are walking off into, unsafe areas and causing problems? So we want to be able to offer services under the auspices of being able to make sure that they're safe, that they have the necessary basic services, but also be able to have some control in terms of where they are deployed. So a lot of customers are coming back to us is, can we not use guest access on private cellular with the ability to tie it to a requirement that the guests bring their own devices, so this BYOD devices. So we looked at this and said, the Cisco ICE, the Identity Services Engine, actually has guest access services today. So when enterprise customers deploy Cisco ICE, they have the option of deploying 3 different models of guest access. They have hotspot, they have self-registered and sponsored guest access as well. And that system is kind of nice because it has all the capabilities that you want. So if you wanted to have, say, sponsored guest access, whereby someone authorizes you as the guest that you're allowed to be on the network for a week, and here's the credentials for a week, there's the whole system is built with the capabilities allowing that to happen. So we in the cellular space wanted to be able to reuse this as much as possible. Obviously, with the understanding that the way you do authentication on a cellular side is a bit different than the way you do typical authentication on the Wi-Fi side. So we had to somehow tie the 2 worlds together on this Cisco ICE guest access model. So the approach that we wanted to take is make it as simple, straightforward, so that the user experience for the guest and the user experience for the enterprise customer is not changed. And typically we have this flow whereby you walk in, you would, as a guest, you would, you would join the guest Wi-Fi SSID that's there. You would automatically get redirected to a portal. The portal will say, "Okay, sign up. If you don't have a username and password already on the system, please click on guest access." And in this case, it's a self-registered guest access, but you can have sponsorship in there as well. So you go to the guest page from a registration standpoint, be able to get the necessary information that's required. What we wanted to do is change one question in that one of those pages that, do you require cellular access? Wouldn't that be nice? In addition to Wi-Fi guest access, it would ask, would you like cellular access? What we can then do is then add a page. If the answer is yes, we somehow fetch a SIM. In this case, it's an embedded SIM or an eSIM profile that the user can then scan into their phone or device that they're interested in being able to join onto the cellular network, or there's going to be a link in there if the device that they want to join is the device that they're using to gain access to the guest access portal pages themselves. So that's the idea. Extend by adding a 1 page to the whole call flow for for guest access on the Cisco ICE solution with the private 5G functionality from an eSIM onboarding process. The question is how? How the heck do you do this? So what we have to understand is that, again, we're marrying 2 worlds together. We're marrying the cellular world as to how authentication is done, how you order profiles, how you get these systems in there, and how you tie it into an the ICE guest access sponsor system itself. So I'm going to walk through very quickly a bit of an eye chart, which is the order and onboarding and managing eSIMs from a guest access standpoint, and show you the results that we've done for integration for this guest access, BYOD guest access for private cellular. But if there's any questions, want to see more details, do send us a note, reach out to your Cisco account manager or SC, and they know how to get a hold of me. We can certainly delve into this more detail than the time would allow us for this particular session. So let's start. So if you were a customer of Cisco, you already have an existing Cisco private cellular infrastructure, you would know that one of the key benefits Cisco brings is that you as the enterprise customers, you can always order more SIMs. You can always order SIMs, and you can decide whether those are physical SIMs, which are those specific chips that you would actually insert into your device, or an embedded SIMs, which is a electronic version of that as a profile. So the administrator for the private cellular infrastructure would say, okay, you know what? I need to top up my inventory of SIMs that I have available, and I want to order 50 eSIMs. You would log on to the Cisco private cellular portal itself, and you will go through the process of ordering additional SIMs. You have to specify some information, your account type, how long you want the SIMs for, and the certain policy access and capabilities you want to have. What happens in the back end is that we would receive that order once it's been validated to make sure that you are still in good standing with Cisco from an account credit standpoint. Order the necessary SIMs from our manufacturer itself in the eSIM factory, and then we would actually provide those eSIMs, those electronic SIMs, into a GSMA-approved centrally managed database. And it's called an SM plus DP system, which is, think of it as a database of these eSIM profiles that you as an enterprise customer would have access to. So at some point, 50 of these eSIM profiles are made available. What we then have to do is then we have to tell the ICE portal, hey, there's eSIMs available. So there's several options that we have here. I chose an option, made it very simple and straightforward. There's a process whereby through API calls, you can actually query the system to say, hey, are there any additional eSIMs available that I can assign to guests going forward? So that's the background. That's how you would order the system. That's how you set the system.
Question on this.
I have a question too.
So, and I love this. I do have one question though about how do you get the eSIM back? Is there a way? Can eSIMs time out, or
yes?
Because obviously you don't want to have to order eSIMs for everybody that walks through the building, right?
Yeah.
Yeah, that would be nice because eSIMs cost money, so it'd be nice if everyone would order eSIMs in perpetuity. But yes, that's a very good question. It's how do you recycle eSIM profiles? So there's a methodology that we actually have put in place through API calls on the ICE portal, so that, for example, if you assign an eSIM to a guest for only 7 days, at day 8, we can actually rip it out, as a TP system, so that the next time, even if the person didn't delete the eSIMs out of their handset and they would attempt to connect to the network, it would fail. That eSIM is no longer tied to his device, and that eSIM is basically put back into that database I just mentioned, the SM plus DP system, so that it can be reassigned to someone else.
Okay.
My question was along those lines, along the eSIM lines, but more along like getting started. Like, how long does it take to process this? Like, let's say I'm ordering eSIMs here. This process you're describing, Derick, is this minutes, days, hours, weeks? What does the process timeline look like?
Yeah, so most of it's API driven, so it would take seconds to do. But obviously there is a checks and balances that we have to put in there from a accounting standpoint. So it takes typically a couple of days to process the orders themselves. Okay, that's why we always recommend that from an inventory standpoint, have more available than just in case God, the CEO is coming in and I need to assign him a.
But what you do, Dan, is you basically have a block in a database, right? So you wouldn't do this. Random contractor just walked into your site. I need to generate. Like you would have an inventory of available eSIMs.
Sure.
And the allocation to that contractor, that is almost instantaneous, right?
Yep. Of course.
The process to improve or like get more eSIMs into your inventory, that takes. A couple of days, like Derick said.
Okay. That makes sense. Yeah, good explanation. Thanks.
So now we're faced with, contractor, whatever, needs to walk in, or you're getting the administrator or the sponsor gets a request, a meeting is going to be happening 3 days from now, and 50 guys are going to show up, and they need access, and they need access on the cellular side. So you would actually, the administrator or sponsor would actually log on to the Cisco ICE portal, and there's a process whereby you can pre-allocate or pre-authorize these guests to be available on this infrastructure. So when they do walk in, they can get the necessary eSIM profiles. So in that case, what we do when the sponsor logs onto the ICE portal, it actually talks to via API calls to the eSIM SM plus DP database system and pre-fetches those eSIM profiles and pre-assigns them to the individual subscribers, the individual guests that need to have access in this infrastructure. So when the guest actually does walk in, whether they get it via email or they get it via printout. Sometimes, people like printout stills, paper, or they get it via text message. You get that QR code that says, "Hey, you want access? Scan this QR code or hit the link to be able to allow for that eSIM profile to be downloaded into your handset." And the cool thing is that when you scan that QR code or you click on that link, your handset, the QR code is coded with a URI, and it tells the handset, "Hey, connect to the eSIM SM plus DP system. Here's the private key. Download that profile, install it as a SIM in your device." So it automatically configures your device to say, talk to this private cellular network with this PLM ID, with this APN or DDN information, and it's tied to your ICC ID, and you can even do fun stuff on the back end to put all these automation rules to say prevent SIM swapping and all that fun stuff.
So, quick question. So, let's say my device is I'm part of Falkner Networks, right? And it's a nationwide carrier, and I walk into Linegar Industries and I want to do this. What happens to my connection to Falkner Cellular?
So, yeah, that's a very good question. Yeah. So in the latest series of standards, when we have the cellular, they have defined for eSIM profiles that your handset is supposed to be able to support multiple profiles at the same time.
Okay.
Right? And these profiles can have priorities associated as well. And typically, the way the priorities from a private cellular is higher priority than the consumer-oriented side. So if you look at your phone and you have 3 or 4 of these profiles, private cellular 1, private cellular 2, private cellular 3, public cellular 1, public cellular 2, they are ordered based on the priority that the providers implement this on, which by the way, you can adjust. You can go in these things around if you know what you're doing.
And the buzzwords here are dual SIM, dual standby, dual SIM, dual active. So these are all capabilities of the handsets themselves that are increasingly becoming important in those kind of scenarios, right?
Yeah. Even seeing handset manufacturers move away from physical SIMs to just pure eSIMs because less hardware to support. I can support more profiles because if you do dual active physical SIMs, they need 2 slots, and the old days of flipping SIMs is going away. Unfortunately, that was fun.
From a user's perspective, though, when they walk in, they will connect to to Linegar Industries, and they'll stay connected as long as they can stay connected to Linegar Industries. They'll stay connected to that. When they walk back out, they're automatically reconnected to Falkner Cellular. Life is good.
Yeah. Okay. So it cycles through the profiles depending on the connection. It will tie the best to the worst. Some people have complained that it doesn't do it fast enough because it tries, and then flips over. And there are, with these SIMs, if you look at this physical SIM, it actually is a chip inside of it. You can actually run applets on these SIMs. And I know of some manufacturers, not Cisco, I know of some SIM manufacturers that have written specialized code to speed up that selection process. So for those customers that need that capabilities, those are available as well, yes. So lots of opportunities we in the industry have to be able to make that experience of how you roam from different providers, public and private and hybrid, a lot simpler and easier to do. Yeah. But that's the way it's going to be done for the cellular space. Multiple SIMs, multiple identities that you're going to have to manage depending on the operator in question. Because a lot of these things are tied to commercial contracts too. AT&T, Verizon, if you have an AT&T SIM or a Verizon SIM, there's a there's a commercial contract. You're paying them for that service. And so they want to ensure that when you authenticate to the network, there is no dispute between, no, that's not Matt Falkner that was connected to AT&T's network. It's Al Dumdei that's connected to AT&T. So this should be a different bill. And that's why that physical SIM or eSIM is so important to be in the handset.
Right. Okay. Super useful. Thank you.
As I said, once the person walks in, scans the QR code, or clicks the link, the phone will automatically connect over the internet. And we're assuming it's a Wi-Fi guest access to this SM plus DP cloud system, pulls down the eSIM profile, configures the phone, sets up the phone, and then it will automatically go, if it's the priority number one, it will automatically try to connect to that private cellular infrastructure and can be connected, and life is good. You have your services. So that QR code is important from an onboarding standpoint. Be aware, this is all tied back to ICE. So you can actually say, this is a guest, he's a contractor, I want him on a separate VLAN, separate SGTs, with AMBR profile set so that he gets less services than my employees get. So you can segregate him, but still be on the same cellular infrastructure as life goes by. And then, of course, at the end of the week, what happens? Because those eSIM profiles, they're not free. You have to pay for them. So you want to be able to recycle them. So the best way to do it is to have the person to be honest and say, okay, I'm done. I'm just going to delete the SIM and life is good. When you delete it, the phone actually talks to the SMTP system. Okay, I'm done. Here's your profile back. Your life is good. But we also have a methodology whereby the system can, ICE can actually do an API call at the end of the day to say, this eSIM profile is no longer associated with this particular person, take it back. So it will delete the association. So the next time the person tries to connect to the cellular infrastructure, it will get rejected.
And just a little bit of flavor here. There's a distinction between invalidating an eSIM profile and recycling it, right? So obviously you want to invalidate it after a certain period of time if your policy dictates that. But then what's also important is that you're able to reallocate it to maybe another person later on.
Yeah, because these things are not free. They're expensive. And it's what the industry sort of calls SIM swapping, if you've ever heard of that terminology. It's going to become more and more interesting in this cellular world where the SIM swapping idea is going to be used in various use cases to be able to push that profile from one device to another device. But SIM swapping is also used to push that profile from one provider to another provider. And that's how that zero-touch model when it comes to cellular services become in place. So when Cisco ships a Meraki box, it has a SIM inside of it, an eSIM, that talks to AT&T. And when the customer onboards and says, I don't want AT&T, I don't like AT&T, I want to go to Dish. Okay, sure. You SIM swap them to the Dish infrastructure, and there's a process behind that as well. But I digress.
Okay. Yeah. No, good. Very good.
So, and of course, when the guest walks out is, so how do we do this? All we had to do is we had to make sure that Cisco ICE system makes the right API calls. So if you know anything about Cisco ICE and the guest access portal systems, there's a way to customize these things. So a lot of customers and our system integrators and partners do that all the time. So they add logos and they change the look and feel of the guest access portals. But you can actually run code inside of these in these pages, and you can run JavaScript inside of it. So we wrote a bunch of JavaScript functions, and this is for one specific SM plus DP system that I'm showing here, one that I operate here in Canada, that we can actually pull the next available eSIM profile for this particular enterprise customer and make it available for the guest. And then what I did is wrote up, we put this code inside of the pages in the guest access systems for the ICE portal. And then we wrote up the system to generate that page that I mentioned before, the success page. So you have access to the blank Wi-Fi network. It was a customer there, and it says, "Oh, if you need access to the cellular network, here's your eSIM profile." I even used the standard QR code generator that we get off the net. It would generate a QR code associated with that activation code that you see in the bottom there, which is that specialized key that the phone needs to activate the SIM. And we also did some fun stuff like, hey, I need to download the activation code because I can't scan it or I can't click on it, so it has a way to print this out. We put some error codes around there so that, for example, if I lost connectivity with the internet, I cannot generate a SIM anymore for whatever reason. There's a default SIM that gives you basic services that is, something that you could utilize with this particular SM plus TP systems. It's a bunch of other error codes. So I show you not only the result page that we've generated using that script language, the JavaScript language that we inserted into the portal, but also how the protocols would interact with that to be able to generate that particular QR code and onboard those customers going forward. So just as a closing, hope to show that our private cellular solution from Cisco is more than just cellular connectivity. Yes, cellular connectivity is very important and very much the rage these days. But what we're really trying to point out to our customers is that it is part of a multi-access strategy, a multi-access architecture for enterprise customers. Not just cellular, it has to be cellular and Wi-Fi and curb and other access technologies like wired, LoRa, and whatnot. And you have to think about handoff. How do you hand off between cellular and the other radio types in a seamless fashion? Okay. The other thing is that we wanted to ensure that we reuse as much as possible existing systems enterprise customers have from Cisco already. Cisco ICE, Umbrella, Thousand Eyes, Splunk, and so forth and so forth. We haven't
Catalyst switching.
Catalyst switching, DNAC. We haven't talked about these systems. We only focus really on Cisco ICE, but the other components are just as important when it comes to efficient operations for an enterprise customer standpoint. It has to be across the whole environment. We are focused on this intent-based networking. The idea behind this is that whatever you intend to do from a policy standpoint on the Wi-Fi side should be seamless, carried over onto the cellular side. There should be no differences, except for radio access type differences natively. But overall, Matt Falkner is Matt Falkner is Matt Falkner, where he accesses via Wi-Fi or cellular. There should not be a difference. Yeah? And of course, we want to be able to reuse common transport infrastructure that's already there. So your existing layer 2 and layer 3 infrastructure that you've spent a lot of money and time and effort building, we should be able to reuse that as much as possible. The solution, as I mentioned in my previous talk in the Unplugged session 70, it is a as a service offer, meaning that we stand behind the solution. We act as your outsourced operations for this particular solution. So there's a Cisco NOC 24/7, follow the sun, that actually manages and operates, lifecycle manages and operates the packet core and its related capabilities behind the scenes. So we make sure the software is up to date, and if there's any issues with this system itself, there's a dedicated help team that will actually respond to these particular issues, do root cause analysis, and be able to fix this based on the SLAs that we sign through our partners to the enterprise customers themselves. So operations in a life cycles, we stand behind the products. We do that on both our partners and our enterprise customers' behalf, and it's added to the larger managed service that includes the radios and all the other components that you typically would want to see from a private cellular standpoint. So at the end of the day, you don't have to worry about, oh my God, I'm going to have to hire 50 Matt Falkners to be able to operate my cellular infrastructure because I have no idea what this 3GPP TS 2029.503 standard actually talks about. Okay. We do, but it's not necessary for an enterprise operations to be able to spend a lot of time, money, and effort to be able to figure that. It is proven. It's not code that some guy has written in his closet last week and made available on the internet for free, and GitHopped it down and compiled it and run it. This code is based on our existing intellectual property we've been running for 20 plus years. both on the IoT side as well as the packet core side, and the capabilities. We've been running this for long periods of times for carriers that we now bring down to the enterprise space. We are
In fact, our core, powers over multiple hundreds of millions of consumer and IoT devices today. So it's really proven technology.
Yeah, people are kind of surprised when I mention things like, do you know that Cisco operates this, not radio, but cellular network for multiple use cases, and we have about 300 million devices active on this network today, and they go, "What? You're not an operator?" No, we're not. But we are building and operating cores that that supports 300 plus million devices today.
Yep.
They're not what you think of. They're cars, they're point of sale terminals, they're meters, they're security cameras. These are the embedded systems. These are the mission critical systems that people want us to operate in a high available operations. So we do that quietly behind the scenes, but that's the experience and the expertise that we bring to enterprise customers when we operate their private cellular infrastructure as well. Last but not least, what I do want to mention is that there's lots of innovation happening on the private cellular side, and it's in two fronts: APIs. So this talk that we just had about BYOD guest access is heavily dependent on doing the right API calls between different systems. But you can think of other APIs that you can also implement with this private cellular world. For example, we can actually integrate our private cellular with, say, something like ServiceNow. A lot of enterprise customers are now playing around with ServiceNow for fault and performance management and other things. And we've already integrated with ServiceNow, just for basic stuff to say, hey, there's an error in this particular device, deal with it. But you can do other stuff as well through the ServiceNow workflow management systems to integrate with Cisco Private Cellular solution as well. SOC operations, the APIs from a SIEM, XDR, NDR standpoint is also very much important. And AI is now becoming front and center from an innovation standpoint when it comes to private cellular and cellular-based systems, because what we want to do is go into more proactive based operations, something called AI ops. And what AI ops means is that can I use the tooling, the machine learning, and the predictive nature of these large language models that are customized for cellular-based deployments to be able to give you a much better experience in terms of managing these cellular infrastructure. Maybe a topic for another
Yeah, I was wondering if are we developing MCP servers, all that kind of stuff. Kind of probably more than we need to talk about for right now. But I'm still stuck. Honestly, I'm still stuck on having 100 Matt Falkners in the same room. You said we're going to hire 100 Matt
I was
Falkners.
thinking,
I've been in a room with one. I'm still trying to figure out how I'm going to survive this event.
and I'm thinking about, is this a business opportunity for me? Should I be cloning myself?
Yeah, cloning has always been a question that my boss has always said to me. He says, Derick, clone you, because if you get hit by a bus, we're going to be in deep trouble.
Having a spare is okay. I don't know about a room full of 100 of them. This is great, Derick and Matt. Thank you for doing this, pulling this together.
Thank you for having
information. Yeah, super.
And
great information.
Al, you can see we're super excited, Derick and I. We could probably go on for all afternoon and talk to you and share with you, because it's really at the forefront of innovation, and what we're doing just gets us all excited.
A lot to be excited about here.
So,
yeah, this was great. I mean, I learn everything, or I learn so much every episode, and this was no exception. So thank you so much. This was a great topic, and thanks for taking a deep dive here with us, Derick and Matt, on private cellular and Wi-Fi and how they're better together. Really appreciate that. And thanks for tuning in this week again. And just want to remind everyone to go out to our YouTube channel, subscribe if you haven't. It's youtube.com/@getunplugged, and turn on the bell, click the bell for notifications so you're notified when we do go live with this content or with new content. And looks like we're good on questions. Otherwise, if you I think Derek had mentioned it. If you want to get a hold of us, you can always reach out to your Cisco account manager. They know how to get a hold of us. You can also email us. We do get emails to the show here, getunplugged@cisco.com. Thanks for emailing us. Keep those coming. And you can also reach out to us on X or Twitter at Unplugged80211 or on Threads, Unplugged Connectivity. So thanks, Al. Appreciate having me back here. And this is a great episode. Looking forward to next episode. We do have our schedule out there. Just wanted to remind viewers, and that is directly below our title bar on our YouTube channel. There's a link. It's the first link you'll see. That's the schedule to our upcoming episodes. There are lots of great stuff planned here in the new year. So thanks again for tuning in. And until next time, stay connected and unplugged.